I'll start by introducing our first speaker, Thuy Dao, who will talk to us about data standardization using BIDS on Neurodesk. Thuy is a third-year PhD student at the University of Queensland, and her work focuses on developing software to enable reproducible neuroimaging and to make computational algorithms to make medical imaging more accessible. Her work spans two main platforms. That is Neurodesk, which provides accessible tools for neuroimaging research, and Deep Science, which delivers advanced medical imaging algorithms in a web-based environment. The aim here is to make cutting-edge algorithms and tools available to a wide range of clinicians and researchers. So yeah, without further ado, I'll give the floor to Thuy. Thank you very much.
Alrighty, thank you for the introduction. Can I share screen now?
Yes, go ahead.
Cool. So, thanks for the invitation to give a talk in this session, and I'm excited to walk you through a very cool gig today. And first, I will go through the outline of this talk that I want to introduce to you a very powerful combination of tools and standards to efficiently manage and process neuroimaging data. And here is the outline where I first will start with Neurodesk, developed by my group to simplify neuroimaging workflows. And in previous talk from Aswin and Stephen, they already covered what it is, why it's important, and our development journey. I will now give you a more hands-on demonstration of how it can make your work easier. Next, I will talk about BIDS, is their brain imaging data structure. And I will briefly explain what it is, how it can help to ensure that your data set is easy to share, analyze, and reproduce. And finally, I will get a little more hands-on with the BIDS conversion, where I walk you through the three key tools within Neurodesk for converting raw imaging data into the BIDS structure. And hopefully by the end of this talk, you will learn about these tools within Neurodesk and how to decide which one is right for your data and also for your skill set. So before jumping into the tutorial, let's quickly recap about Neurodesk and how it sets the stage for using BIDS more effectively. So this platform is initially designed to serve common challenges in neuroimaging by focusing on four core principles. They are accessibility, flexibility, portability, and reproducibility. So our platform would leverage the container technology, which lie in our neurocontainer here, so that it can isolate tools in separate environments. And by that, it will eliminate the dependency conflicts and also ensure your consistent results for your analysis. We also provide three interfaces to fit your preferences. Here is the virtual desktop environment, where you can have access through our Neurodesktop. We also have a command line interface and Jupyter Notebook interface through NeuroCommand, so that user can have access from different hardware resources. So with just one-time setup of Neurodesk, you can have access to a lot of neuroimaging tools from anywhere. And that would include the tools that we will use today for BIDS conversion. Now that we have explored Neurodesk capability, let's take a little step back and look at the raw data that we're going to work with, the DICOM format. So DICOM is the standard format generated by MRI scanners. Even though it's very excellent for capturing and storing raw imaging data with very detailed metadata, it's actually very duplicated across files and then created a lot of redundancy. Another limit of this format is that it produces multiple files per scan, which can be very inefficient for storage and processing. And these limits has been addressed by a new DICOM format called Enhanced DICOM. It's not yet widely supported in all scanners, So all these limitations make DICOM not very ideal for direct analysis or processing. That's why to unlock the full potential of neuroimaging tools, we often need to convert DICOM into a more efficient format such as NIFTY. So the way NIFTY makes your data management simpler is by combining all the DICOM scan into a single file as a multi-dimensional array. And NIFTY is also widely supported by a lot of analysis tools, but NIFTY has a limitation is that it only embeds part of the metadata from your DICOM files. And this is where BIDS formats BIDS standard comes into. And in this data structure, your NIFTY file will be placed in specific directory, and the additional metadata like acquisition parameter will be stored in JSON file, and that way it will complement the minimal metadata in the NIFTY header. And most importantly, we will create a standardized structure that make it easy to run automated pipeline for your analysis. And besides the benefit for storing more metadata, BIDS can bring more to the table to make your work more efficient and impactful, like improving your collaboration by simplifying how data is shared and organized with others. It would help them to work with your data set quicker and understand how it's structured and the content in the data set. This is very helpful when you work with a multidisciplinary teams or across institution. It also saves time making sense of the old data set, especially when that team member who collected the data are no longer around you. And another major benefit is the software compatibility of this data structure, because BIDS is supported by a lot of neuroimaging tools. So having a BIDS compliant data set would help you to easily integrate with this pipeline without a lot of manual reorganization. And finally, BIDS facilitate data sharing, which is very important for many of us. But major neuroimaging database like OpenNeuro would require data to have it in BIDS structure for uploading. So this standardization will speed up the process of curating your data for public sharing. And that would also meet the growing expectation of open science and reproducibility. And here's an example of how it restructured from DICOM folder into NIFTY in BIDS structure. And in Neurodesk, we offer a complete ecosystem for processing BIDS compliant dataset by combining the flexibility of Neurodesk with a lot of BIDS apps and other specialized tools. We can then efficiently streamline every step of the neuroimaging processing pipeline. And now I'm going to show you how to run a complete data workflow in Neurodesk environment, from downloading, converting, processing to uploading to an open repository. I will now change the screen into here. You're gonna be seeing my browser, and there are a lot of ways to use Neurodesk. And today I'm gonna show you how to run it on our Neurodesk Play, which can easily set up in, not even set up, you can have access it on the browser. So you don't have to install anything on your local machine. And in this Play instance here, you will see that it looks very similar, exactly like Jupyter Lab instance, where I already created a notebook. And the outline of the notebook here will first download DICOM data using DataLab, and then I will use this data to convert into BIDS structure using DICOM to next, then HUDICOM, and then BIDSCOI. These three tools are doing the same job, but they have different pros and cons that would differentiate them from one another. And I'm gonna explain to you further when I run through each of them. The next step, I want to show you how to quickly run a very simple processing tool from FSL so that we can just quickly segment the brain from the anatomical image. And finally, I will upload that segmentation to OSF so that you can see how all of these can be run within Neurodesk environment. Let me make that. So let's first start with the step in data preparation, because it's gonna take a longer time to download the data from scratch. So I already downloaded this data beforehand, so we're not gonna do that. I can run you through the command I use to download the data here, which is data.lat, so that we can install this data report and then get the subject from here. And the data set we're using today is a phantom data, and is from the data.lat public data set. So you can see in the left sidebar here is the data set that I already downloaded. And we can see the data, the directory structure in here, where under DICOM, it would have different scan protocol where all of them would have some DICOM scan within it. Now let's jump straight into the first tool that I want to show you to convert DICOM into BIDS, which is DICOM2Next. So DICOM, to use DICOM2Next in this Jupyter notebook, you don't have to install anything because it's already within Neurodesk, but you will have to load it to the environment by running lmod here and also specify the version of the tool that you want to run. And now we can run that tool within this environment. And I'm going to run this before explaining to you. So this command here would run, will first create a directory to store all the nifty file in there. And it would take the input as the data set that I downloaded earlier and output into that created directory. And you can see on the left sidebar here that is already created. You can see loads of JSON and nifty file converted in here. But you can see that it's not really in the BIDS structure just yet. But we're gonna explore this file a little before we're doing that. So let's check the JSON file where it's supposed to store a lot of additional metadata. So you can see a lot about the sequence and the protocol in here, echo time, and a very cool structure from the latest version from DICOM2Next is the BIDGET. So here you can see that it will get to discard this file and also the name for this file as well. So this is an NSCAL image, which not really considered into BIDS structure. So DICOM2Next would suggest you to discard this file instead of moving it into your BIDS structure. And these BIDS, we can inspect another file from MP range where it will suggest this file to go into ANA directory. And also the suggested name for it so that user can avoid name clashes when creating a wrapper for it. So now the next step is to organize this data into the correct BIDS structure. And I have a very simple script here to create the correct, yes, you can see that it's already done that. It will create the directory for ANAD, DWI, FMAP, and font by just checking the name pattern of their nifty and JSON file. I will move them into the correct data, into the correct directory. But you can see that it's still very manual, that not in just one easy step to get into BIDS structure, and it's not complete yet because here I still have the NSCAL file into this BIDS structure instead of discarding them. So even though it's very fast and easy to run it, it can be a little manual if you have a lot of data, like a lot of subjects and session within your data set, because this one only have one subject and one session. So it's very easy to just move things around and maybe delete this NSCAL file. But when things grow, it's gonna get harder. That's why we want something more automated to do the job for us. That's why I want to introduce you another tool called Unicom. This is a very customizable tool to convert your data. And similar to DICOM to NICS, I would have to load it into this environment and then run this command, and I will explain to you after running this. So this command here, it would take the input file as similar to the DICOM to NICS command, and then output it into a directory called UDCOM reprint BIDS. And this, it will convert it into BIDS structure. And this -f here would be the heuristic file that help you to control how information from the DICOM is used to convert into BIDS layout, like the directory layouts or naming scheme. So the cool thing about UDCOM is that you can customize it based on your data structure from the scanner by controlling the heuristic file. And from this tool, they already provide about 10 pre-created heuristics so that you can try and test if it works for your data. But if not, users often have to customize them based on their understanding of the data set. So in that, after running this command, it will always create a hidden UDCOM folder that contains a DICOM info. So you can inspect all the sequence info and protocol info in there so that you can create the custom heuristic based on that data set. But for this data set that I downloaded today, it can easily run using reprint because it's aligned with their data, with the heuristic file that they provide to us. And you can see in the left sidebar here, it already created the data structure in each format, where you can see the source data would contain the zip set of the DICOM file, because this tool would not discard all of your DICOM images. That will store here for you just in case. And then if we go back here, all the nifty file and JSON file would have been reorganized into the correct structure. And you can see that in ANAT here, it would disregard, it will regard all the scale file for you without you handling all of that tasks. And yes, so it's very easy to use if you have the data structure with that align with the heuristic file that they provided. Otherwise, it could be a little steep learning curve to understand and explore the heuristic file for your data. So if you don't have the skill set to manipulate the heuristic file, we have another tool that have the graphical user interface so that user can interact with that easier. That is BIDS. It's also automate the workflow to convert DICOM to nifty and organize your data. That will be slightly different from UDCOM. And for this tool, I'm gonna open the virtual desktop environment, where I go to the launcher and open it up. It'll go into another tab in the browser, but basically they will using the same file system for you. So it's very easy you can easily have access to all the files that we got here. So now I want to go into that directory that we got all the data in there. I believe this is the one, and let's see if we in the right place. Yes, we are. So you can see that the converted file is also in this virtual desktop environment. And to use Bitcoin in this virtual desktop environment, it will be slightly different, where I have to load it using module load. So I will type in Bitcoin with if you tap, you will see the version of the tool that you want to use. And I want to use the latest one within Neurodesk here, which is 4.4.0. And now it should be able to run BIDS command in here. And I will copy that command into there, where I will first need to run BIDS mapper using the same DICOM data that I downloaded earlier, like other tool. So you can see that it's now running and open the BIDS editor. So that's why you don't have to handle any other code behind the scene to manipulate your data, but you can edit it directly in the graphical interface like this one. So you can see that it will map your DICOM into the BIDS output layout like this one with ANET, UWI, etc. And now you can go further to edit that file. And what you want to look at is the BIDS output in here to make sure that you got the correct data type, and also the suffix that you want to include into the file name. So you can see it will give you the template of the file name for your DICOM. And if you're happy with that, you can click OK and save it into the directory that you want to store all the Nifty file. So after that, I can close it, and it now got the BIDS mapper YAML file so that you can run the next step to actually convert and organize your data. So this is the BIDS mapper, BIDS corner. It will take that original DICOM data, and you want to specify the output directory, which is BIDS core BIDS. And in this directory, it already got the map so that Bitcoiner can understand how to map from your DICOM into the specified BIDS structure. So now we should have that in here as well. So now you can see that is already convert everything very easy, very quick. Yes, so the next step after converting your data, you probably want to process it. And there are a lot of tools within Neurodesk for you to explore here. And if it's not there, you can contact us and we're going to add it into the platform as well. But in this example, I want to show you how to use FSL because I'm most familiar with it and it's very easy to run. Similar to other tools, I would have to use Alma to load FSL into this environment. And I got very simple script to take the anatomical image from the converted directory BIDS structure and pass it to FSL tab to run segmentation. So now if I go back in here, it should generate a new directory of the brain structure. And now I want to build it using iPioneer, and you can see the phantom data in here, not exactly the brain, but just the phantom data. And iPioneer is a very cool tool built upon Review, and I believe that Corbini is going to explain more about this library later on. And lastly, I want to share this data to OSF. And I already have my credential in this environment, so I can quickly run OSF upload this data to OSF. And after it's done, I should be able to find it within here in my project, where after refreshing it, you can see that here, so the segmentation file is under my project that you can then share it with anyone that needs to have access to that data. So that is the end of the tutorial, and I want to quickly summarize all the practice that you can apply for your data workflow, so that you can combine the strength of BIDS and Neurodesk for your workflow. Now that we know that adopting BIDS standard is very essential to improve collaboration and also save time exploring new data sets, it's also compatible with many data analysis tools designed for BIDS compliant dataset. And it's also accepted by major neuroimaging database as well. So it's a very cool standard. Then we have Neurodesk that fully support the BIDS compliant workflow in a accessible, flexible, portable, and reproducible manner so that you can have the very easy and straightforward pipeline for your analysis without worrying about anything. Yes, you have to worry about your analysis, but yeah, not the setup. So combining the BIDS with the flexible and reproducible environment of Neurodesk, we want to create a robust foundation for open and collaborative science. And lastly, I want to shout out to our contributors, funder, and supporter throughout the year that make this platform possible for everyone anywhere. And we gladly want your help to this platform so it can be even more possible in the future. Thank you for listening, and I'm happy to answer any question if you do.